Okay, so yesterday I was at the launch for NIRA, the Northern Illinois Rocket Association. We were hosting the Society of Black Engineering students, and they had built a bunch of rockets, Alpha 3s, and we did the launch for them. I was invited as a guest flyer to demonstrate advanced streamer recovery and recovery systems. And again, it's very impressive to show the students what else you can do with your rocket. You got the basic build, but it's like, oh wow, here's what you can do. And I even gave away a few of my rockets to their organization so they could see how to build them. And I'd like to show what happened on a couple of rockets. I had some very, very interesting scientific results, which is what I want to show. I don't have the videos because I could not do that. I was too busy. But I will shoot them in the next couple of weeks. So this is the Baby Bertha. And this Baby Bertha, if we look very carefully, you can see there's a Kevlar cord along this fin here. Then it goes inside. So this one was initially adapted with an internal anchor. I removed the elastic cord and I attached a shock cord along the fin. It goes inside, and then that creates my Kevlar recovery system. As everybody knows, I use Kevlar for all my recovery systems. I don't use the elastic anymore. That's just too problematic. And the Kevlar gives many more options. But this rocket, it went up to about 1,000 feet. And it went up to 1,000 feet because I used this engine in it. This engine is a D16. A D16 in a rocket this small, yeah, it's going to go really, really high. So again, it went to around 1,000 feet, vanished from sight basically. But then the streamer went off, and the streamer is a 50-foot streamer, and it looked really nice. I'd like to show exactly how I set this whole thing up. I did put everything back inside, but here's how this is set up for flight. So we have the Kevlar cord. Notice when I pull this out how easily it just falls down. Again, that's that special winding technique that I showed where you wind it as a figure 8. It looks really, really nice. And the streamer is inside the blanket here, but the streamer is connected close to the rocket body. If you connect the streamer close to the rocket body, the rocket will pull the streamer back and forth and will flutter a lot. If you put the streamer close to the nose cone, the streamer will flutter less, and the rocket body will bounce around a lot. That's okay. They both slow down. You just get two different effects. It'll slow a little bit faster because the streamer is not being pulled back and forth as much when it's attached to the nose cone. Okay, there was one little issue that I had. So you can see everything is all set up the way that I set up all the other rockets. If we open this up, we see inside of this we have a streamer, which is fairly large. This is a 50-foot streamer, and I do use the folded center wind, which works out very, very nice. So it's a 50-foot streamer. But if we look at the Kevlar blanket, we'll see there's a couple little issues. We got a couple little burn spots on it, and it actually burned right through. And if we look at the back, it's pretty black, and we can see there's several burn marks on this. Now, if we take a look at what happened on this, again, let's look at the engineering aspect. We have a problem. What happened, and how do we fix it? This rocket is fairly short. If you measure the engine mount and you got this long shoulder on the nose cone, it leaves only 3 inches inside the body. Well, if this particular streamer is 2 inches long, that gives us only 1 inch to wind up all the cords and to put the wadding in. So the wadding is packed in really, really tight. And one thing about those engines is that they have a tremendous amount of power in them, but also they have a tremendous blast coming out the end, because typically a D engine is something that you're going to put in a fairly large rocket. So the ejection charge is equally scaled up and extremely powerful. And all of that's coming through this little nozzle on the end. And when that happens, this little nozzle is pressed up against the wadding, and it just literally blows a hole through it. I used a huge amount of wadding. Matter of fact, one of the wadding types that I use is a homemade wadding, which is paper towel soaked in baking soda. That actually works quite well. It's very, very stiff. It's much stronger. And when I use this regular tissue-oriented type of wadding, it just blows it into confetti. So this is what happened. I'm still going to continue flying this. I'm going to probably fly it next time on a C engine so that I don't burn it up. And by the way, the recovery was excellent. The guests were very, very impressed. The students just loved watching a 50-foot streamer pop out of a little 1-foot rocket. Being 1,000 feet up, actually the streamer was extremely effective. So this is a very long streamer. The longer the streamer, well, the more flutter you're going to get if you hook it up right. This rocket, though, floated about 500 feet downrange. And with the small forest preserve there, it floated off past the shrubs, past the prairie grass, off into the past the 4-foot reeds and off into the 6-foot reed area. The only reason I found it is that there was a 50-foot sparkling streamer on it at 500 feet. That's the only way I could actually find out where it actually landed. So again, streamers are great. They're easy to switch out. They're easy to hook up. And when you've got a rocket that's 1,000 feet up, it's easy to see. And we got a rocket that's 500 feet away in 6-foot tall reeds. You're not going to see this in 6-foot tall reeds, but you will see this 50-foot streamer. And I need to do a little bit of work on better protecting this blanket. I didn't burn the streamer, but it did do its job in protecting it, but it may get damaged after a few more flights. I may have to replace it. Again, the nice thing about this Kevlar design, everything is put together with knots. I just untie it, put a new blanket in, and I'm done. So see you in a few weeks when I start launching all the other rockets again, and we see the actual footage of videos of what's happening with these streamer rockets.